Hi, I'm delighted to welcome you to the Open Mainframe Summit. Welcome. Today, I will discuss how Open Mainframe project is the key cornerstone project and that innovation layer which delivers cloud experience to mainframe. Hi, I'm Milan Shetti, and I recently joined Rocket Software as the president of its Z Systems business unit. I don't come from the mainframe background. My background has been in hybrid cloud and open source projects. I have worked on projects in open source such as Java, Linux, OpenStack, Hadoop, among many others. And in the hybrid cloud world, I have worked on enterprise storage, compute, networking in many different companies on the hybrid cloud side of things. But unlike me, Rocket Software has been doing mainframe for a long time. For the last 3 decades, Rocket Software has been a partner of IBM and the mainframe ecosystem. And since 2013, Rocket Software has been leading and helping build and curate the open source community around mainframe, as well as this open mainframe project. Its long history with IBM earned it the trust and the responsibility to partner with IBM for porting some of the initial foundational work which was needed to get open mainframe project off the ground. From its beginning, things such as open system character set, ASCII, UTF-8 were helped delivered by Rocket Software. There are many other projects which Rocket Software since its inception been delivered through the open mainframe project. There are 2 pillars in which the open mainframe projects have been delivered by Rocket Software. The first pillar is around making sure there is no version latency. And as all mainframe users would know, different versions and older versions of software do explore or exploit or create vulnerabilities around security. Plug in those gaps and plug in those vulnerabilities. It's very important to make sure that all the tools and the tool chains are all updated, ported. Even the older versions of the tools are ported onto the mainframe environment. So there is no version latency. Rocket Software was the chosen partner by IBM to port all those technologies so that we don't have the version latency in mainframe while mainframe is embracing into the open mainframe world. The second pillar is the innovation pillar. One of the projects I would like to call out on the innovation pillar of delivery into the community of open mainframe project by Rocket Software is its work with the open source project Conda in making sure that all of the open source packages are curated and securely delivered to the open mainframe platforms. That is some very useful and very needed work to get this project adopted into the mainstream enterprises. Projects such as Zoe are also a great example of open mainframe project being going into the innovation areas around experience. Now, having come from the hybrid cloud world, and one of the major lessons which I've learned in my time in that world is that cloud is an experience and not a destination. I'm going to unpack what do I mean by this statement of cloud is an experience and not a destination, and how open mainframe project plays in this discussion. It always helps to go and look at the examples and the references of how the cloud environment is working and what is important and how the adoption curve began. So let me give 3 examples of for a reference standpoint on the public cloud innovation and what was really innovative about public cloud. So let's take the 3 more popular public cloud environment, the AWS's, the Google Cloud, and the Microsoft Azure. So let me start with the AWS. If you think about how AWS is built, the hardware is proprietary and the engine which powers AWS is absolutely proprietary. And what do you mean by that is DynamoDB, as an example, database which runs on AWS, that is a proprietary stack. Hardware, you can't dynamically change, or whatever hardware configurations which are done and what options are available are the options available. You can't go and give a call to the AWS data center admin and ask them for more CPU on one particular server, right? So both the hardware infrastructure as well as the engines which power it are proprietary, kind of built like mainframe. Similarly, Google Cloud. Bigtable is the database. That Bigtable database is proprietary. Microsoft Azure, the SQL engines, and everything are proprietary. But why did public cloud get adopted so much? There are two reasons for that. One is the community which was built around the experiences. So that's the community is a big part of it, and leveraging open source to create that adoption layer. The two reasons why the public cloud are popular today it always centers around experiences. So that is the key to the adoption. How do you build a community for application developers and also community for the operators? So that adoption layer is very critical. And the two reasons, community and experiences for those communities. Using that as a reference, I do want to bring back to the mainframe discussion here. We know that ZOS on mainframe are considered as most secure, highly available, and high transaction processing environment, and hence they are the mainstay of running mission critical application for all enterprises, and hence they are the system of record. Now let's take a step back and see why that is the case. Going back to the lessons of computer science, there is something in computer science called CAP theorem, and the theorem goes this way. You can pick two of those three vectors: consistency, application, and performance. And you can be really good at two, and on how you build distributed systems and everything. Those are the principles which are governing principles around how public cloud applications or public cloud infrastructures are built. That is not the case with ZOS. The reason why it's a system of record for mission critical application is that it breaks the ZOS on mainframe, breaks the constraints defined in the CAP theorem. Again, it breaks the constraints defined in the CAP theorem. You can have consistency, you can have availability, and you can have performance all at the same time. And that's what mainframe becomes and is: the system of record, high transaction processing, secure, highly available infrastructure to run applications. Now, why does it matter for application developers? If the application developers have to write software to factor for whichever the third leg which is missing, whether it's a consistency, application, and performance, that's a lot of work which the application providers have to do it. And this is what been one of the barriers why public cloud providers had a hard time being the system of record in the mission critical environments. But mainframe comes from that background. Mainframe unshackles, untangles, frees from the constraints of the CAP theorem, and it can deliver consistency, application, and performance all at the same time to the application, so the application providers can focus on what they want to focus on, which is building business logic. But what about the cloud experience? And how can all of the goodness which the mainframe environment can provide could be used to deliver a cloud experience for the mission critical applications? It's possible. Much like the CAP theorem, I'll go back to some of the fundamentals of computer science sayings and philosophies. There is one philosophy in computer science which is very important in helping define how open mainframe projects help deliver the cloud experience for mainframe. The philosophy in computer science, this philosophy in computer science goes, you can solve most or any problem in computer science with a layer of abstraction. And that layer of abstraction is, for the experiences, is the open mainframe project. And all of the tool chains which have been developed from Bash, Python, R, and all the machine learning languages which it all brings to, that is key to delivering cloud experience to mainframes. So if you are an app developer, what does this give you? With all the modern tools ported through in an open way and a secure way to the open mainframe projects and have experiences as Zoe applications been delivered on top of it. If you are an application developer, what you get is you could do your test dev or your development in any of the public cloud, but when you are going into production with your system of record information and highly secure environment, you could just move back and forth between the public cloud and a mainframe with a cloud experience. That agility is what is very important. And hence cloud is an experience and not a destination. You as an app developer would want to have that freedom to develop anywhere, deliver and build and deploy into production from anywhere. That workflow is your choice. And this abstraction layer on top of mainframe, which open mainframe project provides, delivers that. Hence, for app developer, cloud is an experience and not a destination. They can continue developing their applications wherever they need to and with the tool chain which they are very familiar with. An example is MongoDB. MongoDB, if you are very familiar with MongoDB and you're using MongoDB as the database for your cloud application, that same MongoDB is now ported onto open mainframe through the open mainframe project. So which means it doesn't matter where you are and what your tool chains are, they are available through open mainframe projects. So hence cloud becomes an experience and not a destination. So very foundational and very innovative work which has gone on to the open mainframe project. So what does the roadmap look like? What I believe, by having open environment and all the tool chains which are available from public cloud also on the mainframe now, the two dimensions of innovations which it springs are cloud, hybrid cloud, and what I call tangible AI. Let's talk about hybrid cloud here for a second. Moving data to workload is hard, time consuming, error prone, and honestly, just you need to know a lot more about the data than the application developer would want to care for or need to know about. What if we bring workload to the data? You can, rather than bringing data to the workload, you bring in workload to the data. That is something which hybrid cloud, the vision of the hybrid cloud can be delivered with the foundation layer as the open mainframe project, because there is consistency in the tool chains, there is consistency in the abstraction layer which has been provided. So where I see open mainframe projects developing further, now that the foundations are there and innovative projects are coming in, is becoming the enabled technology for hybrid cloud. Bring your workload to the data. There's a lot to, from a value proposition standpoint for app developers. Similarly, for sys administrators, whether it's a sysprog in mainframe or whether it's a site reliability engineer in the public cloud provider, embedding the artificial intelligence libraries and also building applications using those libraries to make operations simple in the hybrid cloud environment or the private cloud environment or the mainframe environment is very valuable, which helps identifying problems, rectifying problems, and also predicting where problems could be occurring. It's a very valuable tool, which I call the tangible AI here, is relevant for the sysprocs, the SREs, and the operators of the data centers or the cloud environment. So what this says is Open Mainframe project has done amazing amount of, I'm impressed by the strength of the community and the software technologies which are available in it, and it's foundational to the roadmap of hybrid cloud and the tangible AI. Hence, ladies and gentlemen, cloud is an experience and not a destination. An Open Mainframe project is the cornerstone innovation layer which makes mainframe a secure hybrid cloud. Thank you very much for your time and enjoy the rest of this summit. Thank you.